So we're going to talk about conditionals and logic. So what that means is using if statements so we can run some code only sometimes. So conditional is a code that only runs sometimes when a specific condition occurs, hence conditional. So we can do this with an if statement. And the syntax for an if statement, we just type if and then some sort of Boolean expression. So I'm just going to put that right here for now. Boolean expression. And then we have the body of our if statement. So what do we mean by Boolean expression? So a Boolean is a type of variable in programming. And that means we can declare it in Java. If I say Boolean, and then we need to give it a name. So I'm just going to call it B for now. And we can set it to a value of true or false. And those are both values that are baked into Java. So I can say Boolean B equals true, just like that. And now I've declared a Boolean value. And I can take that Boolean and put it here. I can say if B. And now whatever we put inside of these curly brackets will run only if B is true. And now in this case, we set B to true, so this code will always run. So I'm going to type in here, B is true. And if we run this, sure enough, it prints out our message at the bottom because we did set B equal to true. If we set this to false, say Boolean B equals false, now if I run this, it doesn't print anything at all because B was false, so evaluated to false. Our code is conditional, so it only runs sometimes. A Boolean expression is any expression that evaluates to true or false. So it doesn't just have to be true or false. We can put some stuff in there. And I can also, just like ints and floats and all of those, we can perform operations on Booleans. So for example, we can use the not operator, which will change whatever Boolean it evaluates to, it'll change it to the opposite. And this is called negating. So we can use the negation operator, which is just the exclamation point. We can say if not B. And now that changes whatever B is. So in this case, it's false. We're going to switch it to the opposite. So now B is true. Or not B is true, I should say. So in this case, B is false. Right? If we run this, B is indeed false. So we said if not B, if the opposite of B is true, so the opposite of false is true, we are going to run this statement. So you can think of the negation operator as like switching a number from positive to negative or negative to positive. So not false is true and not true is false. Yep, I can make this bigger for you. Okay, is this better? Wonderful. Okay, so just to reiterate that one more time, now that we've got the larger text, if we have some Boolean B, and right now it's set to false. If we say if not B, so whatever the opposite of B is, so the opposite of false is true, and because this evaluates to true, now we can run this code, and that code is that B is false because it was the opposite. So this would be an example of a Boolean expression. It's some sort of code that, when evaluated, is either true or false. So if we have like an int, if I said int a equals 10, if I put a in here, a is not a Boolean expression, so we get an error. It doesn't like that. It can't convert an int to a Boolean. However, we can use an operator, arguably the most important operators for Booleans, called comparison operators. And what that means is if I have two ints, a and b, such that we're going to set a to 5, and I'm going to create another int called b. So I'm going to delete this Boolean that we've got up here. going to say int b equals 3, then we can use a comparison operator to get information about A in the way that it compares to B. So that's why they're called comparison operators. To create a Boolean from ints, we have multiple different symbols we can use. For example, we can say Boolean less than equals A less than sign B. And now this is another Boolean expression. We're taking two int type variables, A and B, which are equal to 5 and 3. And we're asking, is A less than B? And the answer to that question is either true or false. It's a Boolean, which means we can store it in a Boolean variable. In this case, we're calling it less than. And now we can type that variable into our if statement. And if A is less than B, then we can do something about that. In this case, let's print out A is less than B. And if we run that, we get nothing because A is not less than B. But if we switch the value of A from 5 to 2 and rerun it, now it does display that message that A is less than B. We can also cut out this middleman here. We don't need to assign this expression into a variable. We can cut it out and put it directly into the if statement itself. So if A is less than B, then print out this message. And so the exact same thing happened. We didn't change anything about our code. We just streamlined it a little bit. So the full list of comparison operators is the less than, which is the less than arrow pointing to the left. We've got the greater than arrow, which points to the right. We've got less than or equal to, which is the way that I remember these symbols is it's always the order that you say it. So less than or equal to is the less than sign, then the equal sign. So less than or equal to. Then we have greater than or equal to. Same thing, it's the same order that you say it. So greater than or equal to. If you switch those around, if you say equal to greater than, it won't work. So you have to make sure that it's the arrow first, less than or equal to, greater than or equal to, in that order. Then we also have equals. And that's two equal signs put together. We need them both because that's how Java knows that we're asking a question. We're saying, is this number equal to this other number? If we only put one equal sign, then Java thinks we're telling it A equals B. We're using an assignment like that. So a single equal sign is for assignment. We're telling Java, I want A to equal 2. And two equal signs is asking, are these two things equal? Then we have not equal, which is when we put the exclamation point or the negation operator and then an equal sign. So again, it's the order that you say it. We have not equal, just like that. If you put the equal sign and then the exclamation point, it won't work. So these are all the operators that we can use to compare numbers. These are our comparison operators. We also have logical operators that we can use to combine multiple Boolean expressions together. And these are the and or operators. So and is two and signs together like that, or ampersand signs, whatever you want to call them. The or operator is two pipe symbols put together, and that's the one that's right above the enter key or below the backspace key. If you hold shift and press that key, that's the pipe operator. So if I take these ints, A and B, and I ask into this if statement, if A is equal to 3, or if B is less than 5, or I'm sorry, not less than, greater than. Right, and I'm going to change this message to just say true. We run it. This doesn't print out because A is not equal to 3, A is 2, and B is not greater than 5, B is 3. So neither of these expressions evaluated to true. If we use the OR operator, at least one expression has to evaluate to true. If any of them evaluate to true, then the whole thing is true. So if we change B to 7, for example, and we rerun it, now it does print out true, right? Because 7 is greater than 5. Even though A is not equal to 3, we still get true from this because we're using OR, these two pipes. If I change this to AND, so A has to be equal to 3 and B has to be greater than 5. If we run it again, now nothing gets printed out because this entire expression was false just because of A equals 3. But if we change A so that it is equal to 3 and we run it, now it's true again because both of our expressions, A equals 3 and B is greater than 5, both of them are true. So the whole thing can be true now. Okay, so we're using two symbols here when we say and or, right? Two ampersands, two pipe operators. The reason we do that is because of something called short circuiting. And all that means is because both of these expressions have to be true for and, if we're putting and in there, since both of them have to be true, if one of them is false, that means the whole thing is false, right? So short circuiting allows us to ask, okay, if A is 2, if we check is A equal to 3, we know that's false because 2 is not equal to 3. We can stop there because we know since this is false, the whole thing is false because and requires both of them to be true. So if this is false, we don't have to check anything else. We know that the whole thing is false and we can move on. So it makes it a little bit faster. If this expression here, let's say it took 10 seconds to run that second expression, by using short circuiting, we could save 10 seconds because it wouldn't have to check that second part. So it just depends, it is technically faster, but it really just depends on how much faster. And so both of these expressions, the and the or, they'll both use short circuiting. So if I wanted to do the same thing with or, the short circuit would be if the first expression was true. So if I said, if A is greater than 0, or if B is greater than 5. And again, this would short circuit it because we check, okay, is A greater than 0? And we look, yes, 2 is in fact greater than 0. That means this is true. And because we have an or here, this whole thing is true. We don't have to check the second part here. So that's short circuiting. It just allows us to save a little bit of time, a little bit of computation, because we can stop checking our if statement sooner based on if we know the answer to it already. Because if this is true, regardless if this is true or false, we're still going to get true for the entire thing. Okay, now if we don't want to short circuit it, we can just remove one of these operators. So now if I just put the single bar, the single pipe, this will not short circuit. It'll still know it's true, but it'll check this expression anyway. There are some very specific cases where you do want to check every expression, but that's more getting into some advanced coding. So just for now, I recommend using both symbols because it will be very, very slightly faster. And that works for both the and the or. We can just use a single ampersand or a single pipe, and that won't short circuit it. But I'm going to add this back in. Now we can do more with this if statement as well. because we can check some sort of value, but then we can check another one if this one isn't true. So in this case, let's say, I'm going to drag these down so that we can see them. Let's ask if A is less than 1 and B is greater than 5. We'll print out A if that's true. If it's not true, then we'll print out B. We run this and it prints out B. Because if we look, A is not less than 1. A is 2, which is greater than 1. So this whole thing evaluated to false. So we skipped over this. We didn't run this code. Instead, which is what else means, instead, we ran this code. So we printed out a capital B. Now this else part, this part is optional. You can add this or you can not add it. But it's the same as saying it's not, right? So if I just have one expression, if I say if A is equal to 1, then this would be A is 1. But if this is false, right, the else is the same as saying A is not 1. Right? So essentially this is A does not equal 1, which is one of our comparison operators up here. So if I rerun this, we know A is not 1 because A is equal to 2. If I assign A equal to 1 and rerun this, we do get that A is 1. So the else is just everything else was false. We didn't run our if statement. So we're going to run our else statement instead. But if we do run our if statement, if this does come out to be true, A does equal 1, we don't run our else. So these are considered mutually exclusive. Only one of them will run, but not the other. Now we can also add an else if statement in between. So I can say if A equals 1, we'll print out that A is 1. Else, and I can put another if here, if A is equal to 2, we can say A is not 1 and A is 2. Right? And we know that A can't be 1 and 2 anyway. So really this just evaluates to A is 2. And then we can also throw an else onto here. And this would be that A is not 1 or 2. So A is neither 1 nor 2. Oops. So we print this. We still got that A is 1 because we never changed it. If we change it to 2, now we get that A is equal to 2. But if we change it to 3, now it prints out that A is neither 1 nor 2. It's something else. It's something different because it ran this check. It said, is 3 equal to 1? No. It moved on. Okay, in that case, is A equal to 2? And again, it said no. So it moved on. And then we just ran into our else. So this runs if everything else is false. So we get, okay, A is not 1 or 2. And it's important to understand that these else statements, these else ifs and else, only run if everything else before it was false. So if I said if A equals 1, do this, right? But if it's not 1, do something else. So if I said instead of if A equals 2, if I say if A is greater than 0, then do this. So A is positive. And in this case, if both of those are false, then A is negative and not equal to 1. Which, if it's negative, then we already know it's not equal to 1. Or I guess it could be 0, which is not negative. But either way, if I run this, we get that A is positive. So A is not equal to 1. We know 3 is not equal to 1. But 3 is greater than 0. So it prints this out. But if we change this 3 back to a 1, this evaluates to true. So it prints out A equals 1, and then it stops there. It doesn't check any other statements, right? So A is 1, this is true. This is also true. A is greater than 0, but it didn't print out this message because, again, whenever we have an if, else, anything like that, when you expand on that if statement, it's mutually exclusive. Only one of them can be true at once. So if A is equal to 1, we're not going to check if it's positive. And if A is positive, we're not going to do this. Or if A equals 1, we're not going to do this. So only one of these bodies will run. And one last thing, we can chain together as many else if statements as we want to. So we could have 0, like we had before, where it was just if do something, or you could have if do something else, right? And then we can chain together as many else ifs as we want. So I could say if A equals 0, else if A is greater than 0, else if B is equal to 7, else if A is, I'm going to do A is divisible by 2. And the way that we do that is we use this percentage sign here. If A mod 2 equals 0, and we might talk about this more in a later workshop. At the very least, you will learn this at some point in your college career. So if A is divisible by 2, do something else. And again, we can just put as many else if statements as we want. And then if we want to put an else all the way at the end, we still can. Let me format this to make it look nice. And again, that last else is optional. So we can delete it if we want, or we can include it. It really just depends on the exact problem you're trying to solve, and if you want to run that extra bit of code at the end. But that is the basics of Booleans and conditionals and logic, at least specifically in Java. So we are done pretty early. So I want to open this up to you three that are here in the Zoom call. If you have any questions about anything we covered, or want anything specific covered, or if there's something I missed, feel free to, you can raise your hand or put something in the chat and we'll answer some questions. What is the name of the text editor that I'm using? This is Eclipse. I can include a link to where to download this, but if you just go to Google and you search for Eclipse, especially if you type Eclipse Java, it should be one of the first results that comes up. It can be a little slow to install. I know in the past there have been problems where it's even taken overnight to finish installing or downloading or whatever it was. I want to say that problem has been resolved, but I'm not entirely sure. But I really like Eclipse. It's very, very powerful. There's a lot of shortcuts that make writing code a lot easier. So for example, I don't have to type system.out.println. I can type sysout, sysout, hold down Control and hit space, and it fills out the whole line for me. It can automatically add the main method when you're creating classes. Of course, it has all the syntax highlighting. It has automatic formatting if I hold down Control, Shift, and hit F. And then you'll learn later on that you need to include imports. So for example, you don't have to know what this is just yet. You'll learn very soon. If I create a scanner, I get an error that says the scanner cannot be resolved to a type. And one of my options is I can import it. And so if I hit Control Shift O, that line automatically appears up at the top. And then if I delete this line, if I'm no longer using the scanner, there's this yellow line here that says, hey, you have an import you're not using. Same thing, if I hit Control Shift O, that import automatically goes away. So I love Eclipse. I think it's great. Highly recommend it. It's nice to get a refresher on this topic. I've used it for multiple classes so far, but it's good to review the logic behind everything instead of just writing the code without thinking. Thank you. Yeah, no problem. Happy to help. It's always great to have refreshers, especially if you're, oh, I took a Java 1 in the spring, then the whole summer went by. Now I'm in Java 2 and I don't remember everything from the spring. Yeah, it's always great to recover the old stuff, even if you think like, oh, that was easy, I won't have to go over that again. It's always great to recover your code and those topics.